calculating areas using limits. So now we're going to get the exact answer using limits. Suppose you have the function f of x equal x squared, and you want to find the exact area between 1 and 5. So the number of rectangles is actually going to be n. So the base, delta x, is going to be b minus a. It's going to be b minus a, 5 minus 1 over n. 5 minus 1 over n is going to be 4 over n. Now, let us look at this really carefully. So, you have some function. I don't really care what the function is, whether it's x squared or not. You have some function, and you're going from, you want to find the area from a to b. So delta x, well, that's the base. This here is going to be a plus 1 delta x. And the next rectangle, the next partition will be at our a plus 2 delta x's. And the third one will be a plus 3 delta x. And the next one will be a plus 4 delta x, etc., etc. So now, it doesn't matter whether we do upper triangular, lower triangular, whether we include both the left endpoint and the right endpoint. The reason is because delta x, well, let us look at delta x for a moment. It's b minus a, which is a constant, over n. If n goes to infinity, then delta x goes to 0. So it doesn't matter if we include the first rectangle or not, because that area is going to be 0. And the last area, the last rectangle, it too is going to be 0. In fact, all the rectangles in a way are going to have 0 area. But there's infinitely many, and 0 plus 0 plus 0, an infinite number of times. 0 times infinity is not 0. It may be 0, but it's not always 0. And it's also not always infinity. So it doesn't matter if you understood what I just said, wonderful. But what you do need to understand is why this formula that I'm going to write works. It's going to be the summation as I goes from 0 to n of f of a plus I times delta x times our delta x. Now, I remember this formula, and I will never, well, actually, I don't remember this formula, but I'll always have it. I mean, I just put it down because I can see it. What's happening is this. You have your function. Here's a. You have your function. Now, first, I is 0. So it's f of just a, because 0 times delta x is 0. Now, this delta x having nothing to do with I, it can really come in front. And now, I is 1. So it's f of a plus 1 delta x. And now, I is 2. It's f of a plus 2 delta x's. All the way up to f of a plus plus n delta x's. Okay? Now, why does it end at n delta x's? Well, let's look at this closely. You have a plus n times delta x, which is b minus a over n. Well, the n's cancel, and you have a plus b minus a. Wow, this is beautiful. It works. It ends at b. This really is it. This formula is really correct. And now what we're going to do is we're going to take this formula, f of a plus I delta x times delta x, where delta x is b minus a over n, b minus a over n. So that is, it's really the summation as I goes from 0 to n of f of a plus b minus a over n times I times delta x, which is b minus a over n. And what we're going to do is we're going to take the limit as n goes to infinity of either this function or that formula or that one. They're both the same. Oops, n goes to infinity. So f of a plus I times b minus a over n times delta x. Okay, that is, summation. The summation of that. That is the formula. So once again, we have f of x equaling x squared, and we want to do this on 1, 5. So delta x is b minus a over n. 5 minus 1 is 4. So delta x is 4 over n. And, okay, and a is 1. So it's the limit as n goes to infinity of f of a, which is 1, plus I times delta x, which is 4 over n, times delta x, which is 4 over n. Excuse me. Summation as I goes from 1 to n, not infinity. Okay, so I'll fix that. It's the summation as I goes from 1 to n, and then we're going to push n to infinity. So we're going to spend a lot of time on just that. And then we'll take the limit. So right now we have this. Well, summation I goes from 1 to n. Now, what is that? Well, f of anything, and boy, that looks like an anything to me, is the anything squared. That's what f does. It squares times 4 over n. You can bring the 4 over n in front if you like. So we have the limit as n goes to infinity of, let's bring the 4 over n in front, the summation of this. But that's something squared. So we get the first squared plus, we get the first times the second times 2. Well, multiplying by 1 doesn't do anything. We get 8i over n. 8i over n plus that squared. So that's I squared, 4 squared over n squared. 16 over n squared, I squared. 16i squared over n squared. And then we invoke the distributive property of sigma. 4 over n. We can, this I goes from 1 to n. We can take the summation of 1 as I goes from 1 to n plus the summation of that. But I can pull out the constant 8 over n. I just have the summation of I as it goes from 1 to n plus the summation of that. But in front of the summation, I can pull out 16 over n squared and just take this summation of I squared. And now we have a little bit more. So almost all of this has been algebra, if not all of it. I mean, only calculus I've been doing is writing limit. The summation of 1 is just 1 times n plus this is 8 over n times the summation of I, which is n times n plus 1 over 2, and the n's cancel, plus the 16 over n squared times the summation of I squared, which is n times n plus 1 times 2n plus 1 over 6. And this n kills off one of those two n's. So we have the limit as n goes to infinity. And let's clean up what's inside. We definitely have our 4 over n factored, and this is just n. 2 goes into 8 4 times, so this piece becomes 4n plus 4, distributing the n, the 4, and this becomes 8 over 3. So we have 8 over 3n times 2n squared plus n plus 2n, that's 3n, and finally plus 1. Okay. Now, inside these parentheses, let us get a common denominator. And that common denominator is going to be 3n. So I need to multiply that mess by 3n over 3n. So now I have a common denominator. So all algebra. So when I factor out the common denominator, n times 3n is 3n squared. And now I'm going to have, for the numerator, 3n squared. Now something is bothering me there. Okay, so this really becomes 5n plus 4. Because n plus 4n is 5n. When I multiply it by this 3n in front, I get 15n squared plus 12n plus 16n squared plus 24n plus 8. Just distributed their 8. This is the limit as n goes to infinity of 4 over 3n squared. We have 15n squares, and I'm adding 16 more. That's our 31n squared plus 36n. Don't forget the plus 8. Okay, let us just distribute the 4 and realize the whole mess is going to be all over 3n squared. So I get, I guess, 124n squares plus 144n plus 32. Now since the highest powers in both the top and the bottom are n squares, the answer is just 124 over 3, which is 41 1/3. And that's the answer to that problem. Let us try another problem like this. Suppose you are told that f of x equals x cubed, and the interval in question is 2 to 10. Find the exact area using sigma notation or sigma style. So the area is the limit as n approaches infinity of the summation as I goes from 1 to n of f of a plus I times delta x times delta x. And, and delta x is b minus a, is the length of the interval divided by the number of triangles, which is 8 over n. So this formula becomes the limit as n goes to infinity of the summation as I goes from 1 to n of f of a. Well, a is 2, okay, a is 2, plus I times delta x, which is 8 over n times delta x. So that's the formula. This is it right there. So let me copy that, move it down lower, and then we will solve for it. I'll copy it, and we will paste it right here. And that's what A equals, the area in question. Now, this piece here has nothing to do with I. It's a constant, so I can write it there. So it is the limit as n goes to infinity of 8 over n times f of that. Well, let's remind ourselves that f of x was x cubed. So whatever is inside the brackets, which I'll write as 8i over n, I need to cube it. In fact, I need to take the sum as I goes to n of 2 plus 8i over n cubed. Now, all algebra from here. How much is 2 plus 8i over n cubed? To make the numbers smaller, realize that I can factor out a 2 from here. It is 1 plus 4i over n all cubed. So I have to cube this and cube that and multiply the results. Well, 2 cubed is 8 times 1 plus 4i over n cubed. Now, you need to remember that a plus b cubed. Well, you're going to have an a cubed, you're going to have an a squared, you're going to have an a to the first, and then you're going to have an a to the 0, which I really won't write. And likewise, so now the a started at 3 and it went down to 0. The b's go the other way. It starts at 0, which you don't need to write, because b to the 0 is 1. So you have b to the 0, b to the 1, b squared, and then b cubed. Then there are some numbers that go in front of each of these terms. And those numbers come from Pascal's triangle. And we want to know the one for the third power. It always starts off with that. Anytime you have two numbers next to one another, put the sum down in the middle. And always put ones on the end. You have numbers in the middle, add them up. Don't forget to put ones on the end. Notice, so 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Put ones on the end. Let's do one more. 5, 10, 10, 5. Don't forget to put the ones on the end. If you look at the second number n, it's 1, it's 2, it's 3, it's 4, it's 5, and 5 plus 1 will give us 6. Put the 1 in the front, and it's 6. We want cube. Go to the one that has 3 in that second position. So the coefficients are going to be what it says. 1, 3, 3, 1. It's going to be 1, 3, 3, 1. Now, since there's a plus here, we're going to add all of them. If it would have been a minus, now, right now we have a plus there. It will go plus, and minus. So those two here their signs would have changed to minus. But we don't have to worry about that. A couple of more comments. B to the 0 is 1, so you don't need that. Because a cubed is the same as a cubed times 1, and you don't need this here. Okay, now, since one of our values, so basically, I'm going to say that's A and that's B. But A is 1. If you have 1 plus B cubed, well, 1 cubed is 1. 1 times 1 cubed is 1, plus 3 times 1 squared is 3. That is, the A's are all 1. So you have 1 plus 3b to the first, plus 3b to the second, plus 3b cubed. Okay, so how much is 1 plus 4I over n? 1 to the third. 1 is 1, plus is plus, b must be all of that, and there's the cube. So you get 1 plus 3 times b plus 3 times b squared, 4I over n squared, plus, I apologize, 1, just b cubed, plus b cubed, where that's b and I have to cube it. So I get 1 plus 12I over n plus, well, okay, so it's 3 times 4 squared, I squared over n squared, plus 4 cubed, I cubed over n cubed. This is 1 plus 12I over n, 3 times 16 is 48 I squared over n squared. 4 cubed is 64 I cubed over n cubed. That there is what this equals. That's what goes right here. That's what goes right there. So I'm gonna copy this. Oops. Actually, need the mouse to copy. Okay, it doesn't want to copy the limit, but we'll deal with that. Eight over n summation. Okay. This is what we have, and this is the limit as n goes to infinity. Now I just want to see one thing very quickly, because we don't want to do this wrong. Okay. So we have 8 over n. Now remember, we factored out an 8 from here. The summation of 8 times, in other words, that mess was 8 times 1 plus 4I over n cubed. And we now know what 1 plus 4I over n all cubed is. It's 1 plus 12I over n plus 48I squared over n squared plus 64I cubed over n cubed. This equals, summation of I goes from 1 to n. I can factor out that 8, and I get the limit as n goes to infinity, 64 over n. 64 over n times the summation as I goes from 1 to n of that mess. And then I'm going to distribute the summation sign. Okay, so this is equal to the limit as n approaches infinity of 64 over n times the summation of 1. I goes from 1 to n of just 1, plus the summation of that, and I can factor out the 12 over n, so it's just the summation of I, plus the summation of this piece, and I can factor out the 48 over n squared, and just take the summation of I squared plus the summation of the last term. And I can factor out the constant and just calculate the sum of I cubed as I goes from 1 to n. Okay, so this is the limit, and then goes to infinity of 64 over n. The summation of a constant n times is just n times the constant. N times 1 is n, plus 12 over n times that. Well, that's n times n plus 1 over 2. The n's cancel. The 2 goes into the 12 6 times. Plus 48 over n squared times the summation of I squared as I goes from 1 to n. That's n times n plus 1 times 2n plus 1 over 6. 6 goes into 48 8 times, and this n kills off one of those n's. Plus the sum 64 over n cubed times the summation of I cubed, which is n squared times or n plus 1 squared over 4. Now 4 goes into 64 16 times, and I kill off 2 n's on the top and 2 n's on the bottom, leaving 1 end on the bottom. Okay, let's clean this up. This is equal to the limit as n goes to infinity of 64 over n plus this. Distributing the 6, we get 6n plus 6 plus 8 times, let's multiply that out. It's 2n squared plus 3n plus 1 over n. There's the n. Plus this. It is 16 times, I'll square the n plus 1, n squared plus 2n plus 1, all over n. Okay. Close the brackets. Now, it looks like the common denominator is n. So I'll multiply by n here and divide by n here, divide by n, divide by n. So everything is now over n. The limit as n goes to infinity of 64 over n, but I'll also factor out that other n. So it's going to be 64 over n squared. Well, you have n squared plus 6n squared, that's 7n squared plus 6n plus 16n squared plus 24n, finally plus 8. And then 16n squared plus 32n plus 16. Okay. Just combine like terms and then we'll take the limit. So we know the whole denominator is n squared. So it's 64 times 7n squares plus 16. Well, I'd rather do 16 plus 16 first. That's 32 plus 7 is 39 n squares. And then we have 24 n's plus 6. That's 30 plus 32 more. Sounds like 62n. And 16 plus 8 is 24. Now, I can factor this out all the way in front. So it's 64 times the limit as n goes to infinity, because I didn't want to distribute. I don't want to multiply 64 by those numbers. That's way too hard. So the answer is going to be 64 times the limit, which is in the brackets, in the box. Well, there's an understood one here. The degrees of the top and the bottom are the same. They're 2. So you're going to get 39 over 1, which is 39. And 64 times 39, well, that's 64 times 40 minus 1. 64 times 4 is 256 with the 0. Take away 64. So it's going to be 2,500 minus 4. 29, well, that's absurd. It's going to be 2,500 minus 4. It's going to be 2,400. And be 2,496. 2496. And that is the limit. I'm going to verify that and then come back and say we're done. And that is the correct answer. It's funny, I used what is the shortcut method and I got the wrong answer. I got 2498, but I checked and I realized I made an error in the short method. So this long method, it works. It tells me the exact area under the curve. Take this with you, that the area in a given a function f of x on the closed interval ab, could even be open interval. I guess that's all you need. The area, so you know, whatever the curve looks like, the area from A to B, this area is going to equal the limit and then goes to infinity of the summation as I goes from 1 to or n. You can even go from 0, it won't matter. F of a plus I times delta x, all of this times delta x, where delta x is b minus a over n. That will tell you the area under the curve of f of x from a to b. And not only does this finish the video calculating area using limits, but this completes the Calc 1 series. I hope you enjoyed it. Leave some feedback and comments. Let me know. Subscribe to my channel. Thank you.